Well, there's hope that NASA contact with the spacecraft launched in 1977.
As NASA says, it has heard from the Voyager 2 spacecraft, which right now is in interstellar space, billions of kilometres away.
Imagine a machine launched over 4 decades ago, powered by a fading energy source, still whispering secrets from the farthest reaches of our solar system.
It's the only spacecraft that's gone by Uranus. It's the only spacecraft that's gone by Neptune. Everything we know about those planets, we know from Voyager.
Voyager 2 was built to explore distant planets, not to outlive its creators or rewrite textbooks on how our cosmic neighborhood really behaves. What if the frontier between our sun's domain and interstellar space isn't a calm boundary but a turbulent shockwave hotter and denser than anything science predicted? And what if Voyager 2's recent signals reveal phenomena that force us to rethink everything we thought we knew about the outer solar system and the survival of human technology itself? Mission launch and historic voyage. Voyager 2 began its journey from Cape Canaveral on August 20, 1977, launched aboard a Titan IIIe Centaur rocket. This mission was a marvel of engineering and timing, designed to take advantage of a rare planetary alignment that occurs only once every 175 years. This fortuitous arrangement allowed Voyager 2 to visit Jupiter, Saturn, Uranus, and Neptune in a single mission, something impossible outside this small cosmic window. From the very start, NASA faced an immense challenge, crafting a trajectory that no engineer could easily replicate today. The early years of Voyager 2's voyage were defined by groundbreaking exploration. Between 1977 and 1990, the spacecraft boldly flew past the outer planets, delivering humanity's first close-up looks at unexplored worlds. It discovered new moons orbiting Jupiter and Saturn, detected previously unknown rings, and even captured images of a colossal dark storm on Neptune, reshaping what we understood about these distant ice giants. Voyager 2 broke boundaries as the only spacecraft to visit Uranus and Neptune, filling gaps that telescopes and theory could not. Yet, despite its impressive accomplishments, the initial mission was planned to last only about 6 years, concluding after the Neptune flyby in the late 1980s. Beyond that point, Voyager 2's survival was always considered unlikely, as its power source steadily decayed and repairs became impossible. The mission had a defined end date, and continued operation past that was seen as a bonus, a testament to NASA's ingenuity and the resilience of the spacecraft's design. What is striking, however, is how Voyager 2 outlived nearly every expectation, continuing to send back data decades after it had left the realms of the planets behind. This longevity transformed it from a planetary explorer into a pioneer of interstellar space, delivering insights no other spacecraft had reached. The quiet endurance of this machine has become as remarkable as the discoveries it made, and its transmissions continue today, despite power shrinking year after year. Voyager 2's journey is not just a triumph of technology, but also of vision. The planners understood the rarity of the planetary alignment and crafted a mission that optimized every second of opportunity. Their gamble paid off handsomely, sparking an era of space exploration that still captivates the imagination. It remains a testament to what was possible with ambitious physics, precise engineering, and a little cosmic luck. But as the mission grew beyond its initial scope, the questions Voyager 2 began to answer became less about planets and more about the limits of the solar system and what lay beyond. Crossing the boundary from familiar territory into the unknown, Voyager 2 still whispered secrets, fewer and fainter, yet profound in what they revealed. Its voyage teaches us that exploration often continues past the point where most expect it to end, and that surprises await those who persist. The mission's early achievements set a foundation, but the real surprises were still ahead. Voyager 2 was about to cross a line humanity had never crossed before, the edge of the sun's influence and the beginning of interstellar space. What it found there challenged decades of theory and forced a reconsideration of how our solar system interacts with the wider galaxy. Today, knowing the spacecraft is more than 143 astronomical units away, a distance so vast that radio signals take nearly 20 hours to travel, adds perspective to how extraordinary its continued communication is. The thin thread of connection to Voyager 2 spans billions of kilometers, a reminder of both human persistence and vulnerability in our quest to understand the cosmos. The story of Voyager 2's launch and travels prepares us to grasp how unexpected its later discoveries would be. The celestial frontier it crosses is unlike anything once imagined. Even the greatest journeys have moments that redefine everything that came before, and for Voyager 2, that moment arrived beyond Neptune and soon after the solar system's final frontier. Unpredicted interstellar boundary. Far beyond the planetary orbits, Voyager 2 crossed a boundary that had eluded direct observation until November 5, 2018, when it entered interstellar space. This region lies beyond the heliosphere, the protective bubble created by the solar wind surrounding our sun and planets. Scientists expected this transition to be gradual, a gentle fading from the familiar to the mysterious. Instead, Voyager 2 revealed a boundary far more violent, sharper, and unexpectedly hostile than anticipated. Its instruments recorded a sudden, almost shock-like increase in plasma density, jumping as if through an invisible wall, rather than drifting smoothly from one environment to another. Where models predicted a softly diminishing solar influence, the reality was a compressed, turbulent shock front, hotter, denser, and chaotic. This discovery overturned decades of theoretical models that shaped how physicists envisioned the solar system's edge. Perhaps most striking was the temperature Voyager 2 measured in this region, between 30,000 and 50,000 Kelvin. For comparison, this is tens of thousands of degrees hotter than most expected in what is otherwise one of the coldest, emptiest places humanity has ever explored. To find such heat at the solar system's edge rewrites assumptions about the physics governing the interaction of solar and interstellar winds. This violent interface is more than a theoretical curiosity. It has practical consequences for future space missions. Engineers and mission planners now face the daunting challenge of accounting for a turbulent, hostile environment when designing probes to journey farther into the galaxy. The vision of a quiet transition out of the solar system has given way to a more complex reality, with energetic forces at play that could threaten spacecraft durability and data transmission. Voyager 2 did not simply pass a boundary on a map. It found living evidence of an unseen turbulent rift separating the Sun's domain from the galaxy beyond. Each faint radio pulse it sends carries the story of this cosmic confrontation, broadcast from a spacecraft powered by less energy than a refrigerator light bulb. These revelations highlight the fallibility of theory divorced from direct data. For 6 decades, physicists relied on best available mathematics and indirect measurements. Voyager 2's crossing shattered these assumptions, forcing a fundamental revision of our understanding of our place in space. The spacecraft's findings sparked new debates and encouraged updated models of the heliopause. Researchers must now explore how such a compressed, hot boundary formed and what it means for the flow of matter and cosmic rays in this region. With each transmission spanning nearly 20 hours one way, the deliberate and slow arrival of new data offers a humbling window into the dynamic processes at the edge of everything familiar. What Voyager 2 is revealing is not only about distance, but about complexity, the universe refusing to conform to neat predictions. The spacecraft's continuing journey beyond the heliopause sets the stage for mysteries yet deeper and perhaps more unsettling, connecting what we know about the solar system's inner sanctum to the vastness beyond. This journey from the known into the unknown leads us back to another enigma. Voyager 2 first encountered decades ago, one that reveals how even the planets close to home can surprise us. Uranus radiation mystery. When Voyager 2 flew past Uranus in 1986, it encountered something entirely unexpected. Its instruments detected electron radiation belts so strong and intense they defied predictions based on previous observations of the solar system's radiation environments. Compared to other planets, Uranus's radiation zones were far more formidable, puzzling scientists for decades. For nearly 40 years, this anomaly remained unresolved. Voyager 2 provided the only close-up data humanity has ever collected on Uranus, and no new missions followed up to verify or explain the readings. This solitary data point became an enduring puzzle that quietly chipped away at confidence in our understanding of the outer solar system. Uranus, it seemed, became a world that resisted easy explanation. Recent research from the Southwest Research Institute, however, has begun to shed light on this decades-old mystery. They propose that Voyager 2 simply flew through Uranus during a rare, intense solar wind event known as a co-rotating interaction region. This disturbance temporarily energized Uranus's radiation belts, inflating the intensity observed by the instruments. In other words, the extreme radiation levels were not a permanent feature, but the result of Voyager 2 flying directly through a cosmic storm, a hurricane in space caused by solar wind variations. Scientists essentially spent 4 decades mistaking a moment of turbulent weather for a baseline state. This realization dramatically shifts how we view our knowledge of Uranus. If the measurements that defined textbook understanding were a snapshot during a freak event, then much about this distant planet remains unknown. It underscores how limited our perspective still is, even in the age of space exploration. The case for sending a new spacecraft to Uranus has grown stronger as a result. Current models and mission proposals aim to revisit the planet long after Voyager 2's brief encounter, seeking to map its environment under more typical conditions. Voyager 2's experience at Uranus exemplifies how even extraordinary data must be interpreted cautiously, especially when it comes from a single brief encounter. It teaches humility in the face of cosmic complexity and the need for continued exploration. As Voyager 2 whirs ever onward toward the stars, the mysteries it revealed at Uranus remain an open invitation to learn more about the worlds orbiting our Sun and the forces shaping them. From the chaos of a solar windstorm to the calm beyond our solar system's boundary, Voyager 2's journey challenges us to revise how, and how much, we truly know about our cosmic neighborhood. Hovering at the edge of everything we once considered the final frontier, Voyager 2's aging instruments continue to speak, reminding us that exploration is never truly complete and that the universe always has more to teach. Power decline and instrument shutdowns. Voyager 2's power comes from 3 radioisotope thermoelectric generators, or RTGs, which convert heat from decaying plutonium into electricity. At launch in 1977, these generators produced about 470 watts of power combined. Since then, that output has continuously declined, roughly halving every 87.7 years. Spread over nearly 5 decades, this slow but steady drop has left Voyager 2 with only a fraction of its original power today. This decline forces NASA to make difficult decisions each year about which instruments to keep running and which to switch off permanently. Every choice is irreversible. Shutting down one instrument means sacrificing valuable scientific data to preserve enough energy to sustain the rest of the spacecraft's operation. It's a brutal balancing act between preserving mission longevity and maintaining meaningful research capabilities. By October 2024, NASA had to make a major sacrifice, permanently deactivating Voyager 2's plasma science instrument. This was one of the 5 original science instruments still operational until then. The shutdown aimed to save power for the remaining equipment, focusing on maximizing what the spacecraft could still accomplish in its waning years. Yet, NASA engineers have shown remarkable ingenuity to push these limits further. In 2023, they discovered a small reservoir of backup power originally reserved solely as a safety buffer for the spacecraft's voltage regulation. This reserve was never intended to run instruments, but NASA decided that the slow decline of this emergency power indicated the emergency was effectively already here. By redirecting this backup electricity toward active use, engineers delayed the shutdown of another key instrument that otherwise would have gone dark years earlier. This move bought precious extra time, prolonging Voyager 2's scientific lifespan by months or even years. But this trick comes with a catch. It only works once. There is no second hidden reservoir, no secret backup to the backup. Every additional watt of power now spent keeps Voyager 2 alive by dipping into resources never intended for normal operations. NASA is essentially drawing from an emergency fund that will soon be exhausted, underscoring just how fragile the mission's final phase has become. As of early 2026, both Voyager 1 and Voyager 2 have just 3 active instruments each, with plans already underway to pare that number down to 2 before the end of the decade. This shrinking toolkit limits the scope of data the spacecraft can collect and relay back to Earth. Each year without failure is a bonus, but the margin for error is razor thin. NASA's project scientists have been candid about the harsh reality. The spacecraft's operation could end abruptly at any moment. Components can fail, voltage can fluctuate, or simple wear from half a century in space could bring the mission to a close without warning. This uncertainty adds an emotional weight to each surviving signal Voyager 2 sends. The spacecraft's fading power supply is not just a technical issue. It is a ticking clock on a profound human achievement, a reminder that even our most advanced creations are subject to time's relentless grip. Yet, as long as the power holds, Voyager 2 continues to share groundbreaking discoveries from the farthest reaches of space. It is a machine slowly being switched off piece by piece by the very people who care for it most. An unforeseen challenge soon reminded NASA just how tenuous that connection truly is. Near loss of communication. In a moment that could have ended decades of dialogue, a routine command sequence sent to Voyager 2 accidentally tilted its antenna just 2 degrees away from pointing directly at Earth. 2 degrees might sound insignificant, but at a distance exceeding 20 billion kilometers, it made all the difference between a faint whisper reaching home and complete silence. For a spell, NASA lost contact with Voyager 2 entirely. No signals came back. The spacecraft humanity had built a relationship with for over 50 years simply stopped responding. Not because it failed, but because it was physically facing the wrong direction. Its fragile dish antenna was pointed into empty space, away from the only planet capable of hearing its voice. Engineers faced a heartbreaking task. They had to wait and hope. There was no way to physically adjust the spacecraft from here. So NASA had to rely on the onboard programmed safety routines and momentum to eventually reorient it correctly. To aid this, ground teams sent the most powerful transmissions ever broadcast from Earth, using the largest antennas available to shout at Voyager 2 in the hope it would realign. Miraculously, it worked. The spacecraft's automated systems kicked in, realigning its antenna back toward Earth and restoring the precious communication link. But the margin of success was far thinner than most realized. A difference smaller than the width of a thumb held at arm's length nearly made history's longest contact with a human-made object end abruptly. This incident highlights the fragility of the connection, the delicate thread linking our world to a distant traveler powered by decades-old tech. The fix was not a flashy technological breakthrough, but a testament to patience, physics, and hope that programmed responses and calculated transmissions would win out in the void. The incident serves as a humbling reminder of how vulnerable even our most ambitious space missions are to the smallest details. The journey Voyager 2 has taken across the solar system and into interstellar space rides on narrow margins and improbable persistence. For all the marvels it has revealed, every day Voyager 2 continues to transmit is a gift. Every moment of communication is a chance to learn something new about the universe and about the endurance of human ingenuity. But the clock is ticking louder than ever, and the next crisis might not have such a fortunate ending. This hard-earned resilience sets the stage for what comes next, an uncertain future for this extraordinary mission and the profound questions it leaves behind. Engineering ingenuity and extended mission. As Voyager 2's power supply dwindled, NASA engineers refused to accept the spacecraft's decline as inevitable. Facing a mission stretched well beyond its original timeline, they innovated with every resource available to squeeze more life from a dying machine. In 2023, the team discovered a small reserve of backup power, originally intended only as a safety buffer for voltage regulation. This power was never meant to sustain instruments, but NASA made the calculated decision that the mission's slow decline qualified as a de facto emergency. By tapping into this reserve, engineers managed to keep a critical science instrument operational longer than previously thought possible. This unexpected extension bought months, potentially years, of additional data collection, pushing Voyager 2's lifetime beyond early projections. While this was a remarkable triumph of resourcefulness, It also underscored the fragility of the spacecraft's remaining lifespan. This power reservoir was a one-time resource. Once used, there is no additional hidden cache to draw from. With no secret backup beyond this, NASA now faces a stark reality. Every extra watt drawn speeds the spacecraft toward its final shutdown. The ticking clock that was once long and steady now accelerates with bare essentials holding the mission together. By 2026, Voyager 2 relies on just 3 functioning scientific instruments, down from its original suite. Plans are already in place to retire yet another instrument within the decade, limiting the scope of what can still be explored from this aging sentinel. Each day of continued operation is a bonus. Each shutdown narrows the window through which humanity receives whispers from deep space. This ever-tightening margin forces hard choices and tough prioritization. NASA engineers wrestle with maintaining those instruments most crucial to path-breaking discoveries, balancing scientific value against available power. Their commitment transforms Voyager 2 from a simple probe into a testament of endurance and dedication. NASA's project scientists openly acknowledge the mission's precarious state. On any given day, a voltage anomaly, instrument failure, or other unpredictable event could abruptly silence the spacecraft, ending an extraordinary era of space exploration that began nearly 50 years ago. There is profound tension between imminent loss and the hope for one more revelation. Yet, even as it fades, Voyager 2 continues to teach. Every signal sent from over 13 billion miles away deepens our understanding of the cosmos and challenges assumptions. The mission stands as an homage to human ingenuity, adapting and fighting to extend the life of a machine long past its original expiration date. Behind every pulse and transmission is an entire team's work to keep the spacecraft alive against incredible odds. Their creativity and perseverance allow Voyager 2 to go quietly, where no other machine has gone before, honoring the courage of explorers past and present. This spirit of resilience is not just technological, but deeply human, transforming a fading spacecraft into a symbol of hope, poised on the edge of the infinite. Despite the dwindling power and endless distance, Voyager 2's legacy continues to ripple through the history of spaceflight and the future of cosmic discovery. The story Voyager 2 carries now extends beyond raw data to what it means for human culture, tied inseparably to what it carries on board. The Golden Record's legacy. Attached to Voyager 2 is far more than a collection of scientific instruments and antennas. It carries a gold-plated phonograph disc known as the Golden Record. This carefully designed artifact serves as an interstellar time capsule, preserving a snapshot of life on Earth. Encoded within it are greetings spoken in 55 languages, images depicting human life and the natural world, and a diverse selection of music from cultures across the globe. Alongside these are recordings of Earth's natural sounds, waves crashing on a shore, wind through trees, and the calls of birds and whales, as well as the steady heartbeat of a human mother. Created under the direction of Carl Sagan and a team of scientists, artists, and thinkers, the Golden Record was intended as a message to any intelligent life that might one day encounter it. More than a technical achievement, the record represents humanity's desire to reach beyond itself. It is not only about exploration, but about connection, an attempt to share who we are with the unknown. The inclusion of art, music, language, and emotion reflects the richness of human existence. It acknowledges both our achievements and our fragility, offering a humble introduction to a species aware of its small place in a vast universe. This idea is echoed in the pale blue dot image, where Earth appears as a tiny speck in darkness. Together, the image and the record express a shared message. Everything we know exists within a fragile point in space. Even after Voyager 2's instruments fall silent and its transmitter fails, the spacecraft will continue its journey. It will drift through interstellar space, carrying the Golden Record with it. Scientists estimate it could survive for hundreds of millions of years, far outlasting human civilization. Over such immense time, continents will shift, climates will change, and life may evolve. Yet this artifact may remain. The Golden Record transforms Voyager 2 into a cosmic ambassador. It carries not just data, but meaning. a message of curiosity, peace, and shared existence. Without words, it extends a greeting across space and time, offering connection to any intelligence that might find it. The thought of the record surviving long after humanity is gone is both humbling and profound. It raises questions beyond science. What does it mean to leave a message for an unknown future? Who might discover it? And how would they interpret its sounds and images? This legacy adds emotional depth to the Voyager mission. It is not only scientific but symbolic, reflecting imagination and the desire to be understood. Each fading signal marks the slow end of a machine and a chapter in human exploration. As the mission approaches its end, the golden record remains a lasting symbol of humanity's place in the cosmos. Even when Voyager 2 falls silent, it will continue traveling outward, carrying our voices, stories, and identity into the unknown. In doing so, it ensures that a part of humanity endures, drifting among the stars long after its final signal. This enduring journey also reflects the power of collaboration across generations, as countless individuals contributed to its creation, operation, and meaning. Engineers, scientists, and visionaries worked together to build something that could outlast them, combining precision with imagination. The golden record stands as proof that exploration is not only about discovery, but about expression, preserving who we are as much as what we know. In this way, Voyager 2 becomes a bridge between science and storytelling, carrying both knowledge and meaning into the vast unknown beyond our solar system. Beyond its scientific value, it remains a quiet testament to human curiosity, courage, and the desire to connect. From the fragile warmth of a battery-powered instrument to the golden echoes of an entire world, Voyager 2 carries both our quest for knowledge and our hope for connection into the infinite. Final countdown and lasting impact. Voyager 2's journey is approaching its final chapter, yet the exact moment when its voice will fade into silence remains uncertain. NASA has no plans to send a rescue mission or attempt repairs. Such an effort would be impossible given the immense distance. Instead, the mission will end quietly and naturally. When the spacecraft's power drops below the level needed to run its transmitter, communication will simply stop, closing a conversation that began in 1977 during the Ford administration. That unknown end date lingers like a distant horizon, slowly drawing closer as Voyager 2 drifts deeper into interstellar space. The decline of Voyager 2's power supply is gradual, but not perfectly predictable. Its radioisotope thermoelectric generators rely on the decay of plutonium, steadily producing less energy each year. However, minor fluctuations, aging components, and the harsh conditions of space introduce uncertainty into the timeline. Engineers continue to manage this decline with remarkable ingenuity, shutting down non-essential systems and redistributing power to keep the most critical instruments alive. Even so, no one can say with confidence whether the spacecraft will continue transmitting for another 5 years or if it might fall silent much sooner. As its energy wanes, Voyager 2 is being forced into a slow shutdown. Instruments that once revealed the secrets of distant planets and interstellar space are going dark one by one. The steady stream of data that has flowed to Earth for decades is becoming thinner, more fragile. Yet every remaining signal is invaluable. Voyager 2 occupies a region of space no other probe has reached, offering a rare and irreplaceable opportunity to study the environment beyond our solar system. Each transmission carries the potential for discovery, reminding scientists that even now, the spacecraft can still surprise us. For the people who have worked on the mission, the approaching end carries a deep emotional weight. Voyager 2 is more than a piece of machinery. It represents a lifetime of curiosity, dedication, and achievement. Generations of scientists and engineers have guided it across billions of miles, watching it exceed expectations again and again. In many ways, it has become a silent companion, an enduring witness to humanity's first steps into interstellar space. When the final command is sent and no response returns, it will mark the quiet conclusion of an extraordinary era. But Voyager 2 itself will not truly end. It will continue onward, coasting through the galaxy at over 15 kilometers per second, untouched and unstoppable. Long after its systems fail, it will remain intact, moving endlessly through the dark between the stars. Attached to the spacecraft is one of humanity's most poetic creations, the Golden Record. This collection of sounds, images, and greetings captures the essence of Earth, its cultures, its voices, its life. It transforms Voyager 2 into more than a probe. It becomes a message in a bottle cast into the cosmic ocean. Even after its instruments fall silent, that message will endure. Voyager 2's longevity challenges our understanding of both technology and time. Built with computing power far less advanced than today's simplest devices, it has outperformed expectations and rewritten scientific knowledge. Its discoveries forced scientists to rethink the nature of planetary systems and interstellar space, proving that even modest tools can achieve extraordinary things. Its ending will likely pass without global attention, a quiet fading rather than a dramatic finale. Yet its legacy will resonate for generations. Voyager 2 stands as a symbol of resilience, curiosity, and the human drive to explore the unknown. Voyager 2's story is one of unexpected persistence and groundbreaking discovery, proving that exploration can reveal truths long after its expected end. Its fading signals carry lessons about survival, curiosity, and the vast unknown still waiting ahead. If you enjoyed this journey, please like and subscribe for more stories that push the boundaries of human knowledge.